Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, what we're going to do is we're going to add frequency modulation to our synthesizer. So FM synthesis is a very popular technique to get more interesting sounds out of your synthesizer, and we're going to talk about how to do that today. So this is one of these tutorials that could definitely start getting into some deep math, but what I'm going to ask us to do is to actually just intuitively think about how FM synthesis works. It's frequency modulation, so we're actually just using a wave to modulate a frequency. So it's changing the frequency of a wave. So before we get started, I'd like to tell you about our audio programmer community on Discord. So we have over 5,000 members in our community, and we'd love for you to join. We have audio developers of all different levels, and you can come join us on theaudioprogrammer.com/community. So let's go ahead and get started, and I've actually connected my iPad here just to give you an intuitive idea of what we're going to do. So I'm going to just, in my horrible handwriting, try to draw a sine wave. So normally if we have a sine wave, we would have something like this, right? Where we have some sort of wave that's going between positive and -1, right? Now, with FM synthesis, what we're going to do is we're actually going to take this sine wave and we're going to use another wave to modify the sine wave. So maybe we might use another sine wave, right? And what we're going to do is we're actually going to use this as a way to modify the frequency. And what you'll end up with is actually something that will look a little bit more like this. So that's something more like what your final wave is going to look like. Okay, so that's what we're going to do in this tutorial. Like I said, a lot of frequency modulation tutorials start getting into some deep math, but we're not going to do that. We're actually just going to rely on our intuition to actually get us through this tutorial. So let's go ahead and get started. So in our last tutorial, as I was saying before, we created our own oscillator class, and where we kind of wrapped the Juice oscillator in some of our own functions. And now what we're going to do is we're going to actually utilize this to start implementing our FM capability. So first thing that we'll do is we will go to our Juice API so I can show you where I'm getting all of this stuff from. And first thing that we're going to do is we're going to create another oscillator, because we need another oscillator that's going to modify the frequency of our first oscillator, right? So this is the oscillator class. We've used this before. So now I'm just going to create one here, and I'll just call this Juice DSP oscillator. This is of type float. I'll just call this FM osc. And I'm going to initialize it. For now, I'm just going to leave it as a sine wave. So in our past tutorial, we had these three wave types that we could do: a sine, saw, and square wave. I'm just going to take the code from this sine wave here, and I'm just going to copy it, and I'm going to initialize my FM oscillator by pasting it here, like so. And hopefully that should work and that won't complain to me. And of course, we need to, anytime we add any sort of DSP process, we need to make sure that we give it the sample rate. So what we need to do is we will say fmosc.prepare, and we'll pass it our process spec that we've done in the past tutorial, so I won't go through that again. Now what we need to do is we need to we have, just walking through where we actually are setting the frequency of our actual wave. We have this function called set frequency, where what we're doing is we're getting an incoming MIDI note number, and then we are converting it to hertz. So that's what's happening here. And what we need to do is we're going to need to add it to some value of we're going to need to get the value of our FM wave and use that to take that that MIDI that frequency and actually change that, right? So what I'm going to do is I'm going to create a float here. So for now, we'll just call it a float, and I'll just call this FM. I'll call it FM mod, and we'll just initialize it to 0. And just for now, just to show you the intuition of what we're looking to do, we're going to take this note. So it may be some frequency. So let's say it's 200 hertz, right? And what we're going to do is we're going to use this modulating wave to actually change what the final frequency is going to be. So what did I call it? I called it FM mod, right? And so ideally, what'll happen is that this value will be between 1 and -1, right? So this is going to be the wave that's going to be modulating the frequency of our main wave, of our main oscillator. Now what we need to do is we need to find out, we need to actually get the value of that wave form at a given point in time. So here in our Get Next audio block, we are actually using this to actually process our main oscillator. And the problem here is that currently what we're doing is we're using buffer size processing in our oscillator, and what we need to do is we need to find the value of this FM wave at one particular point in time rather than getting a block of data. So what we'll need to do is we will need to actually do a sample by sample processing in order to actually get what the value of the wave is at a particular given point in time. So what we could do is we could use a for loop. So what we'll do is we'll say for, oh, that was weird, for int channel equals 0, channel is less than block get num channels plus channel. And then this is the way that we would just normally do sample processing in any other DSP process. And then we need to go into our samples in our channel, right? So we will say for int s, which stands for sample, equals 0. S is less than block dot get num samples plus s. And in here is where we want to do our FM processing, right? So we could say FM mod, which will be a floating point value between 1 and -1, or maybe larger. We will say FM mod equals FM osc, and now we need to do our processing, right? So I think it's process sample. Okay, now what do we put it? Not process, because that's going to want to take a whole audio block. We want process sample, and in here we want a float input. Now what do we think about this for a second? What do you think we're going to need to put in here, right? This block is our audio information, and what we're doing is we're going through the channels in this audio block and the samples in the audio block. And what we need to do is we need to find the sample of this audio block, right? So we need to iterate through this whole block, which is essentially a vector of audio information, and pull out what the sample is going to be at a given point in time. So what we could say here is block, and I believe, yes, it's get sample. And then in here, we just put in our for loop variables here. So in channel, we just put ch, and in sample index, we put s. And that's it, right? So that's how we're getting the value of this wave at one given point in time to use if we're going to actually use FM synthesis to change the frequency of our main oscillator. So now what we need to do is we want to have some modifiers that we can use where we can change the frequency, or we can change how much we want this wave to modify our main frequency, right? So what we could do is we could go to our processor. So these will be user controls that we want to modify. We want to modify how much that we want the user to be able to modify how much that wave will be able to modify the main wave and the frequency that that wave is oscillating at. So sounds to me like the best place to do that would be in the plug-in processor in our audio processor value tree state, right? So this is a list of all the parameters that the user is going to be able to modify, and we can just create two new parameters. We'll call them frequency, FM depth and FM frequency, and we can do that quite quickly. So we'll take this, since these are going to be floating point values, I'm just going to take this and copy this to save me some typing. I'll leave a comment here that will just say FM. And now we have two new audio parameter floats. So this first one we will call FM freak, and that will be short for FM frequency. And then we have this range, which is going to be, what's the range of values? Well, if we don't want any FM synthesis to happen on our wave, we would want that to be 0, right? Now, what about the maximum frequency? Well, that could be just an arbitrary value. So let's just try 1000, right? So that the frequency might be able to go up to 1000 hertz. And we will be able to try this out very quickly by just setting a little arbitrary value that'll have a little bit of FM synthesis. Let's just say that we'll make that 5. So that'll be a 5 hertz wave, 5 hertz sine wave. Now we just need to create an FM depth parameter. So this will be FM depth like this. And then we will change this to depth. And once again, we could probably choose a number of different values here of how much we want the depth to be. So if you think about it, right? So the depth is kind of the gain of the how big we want this wave to be. So normally a wave would be oscillating from -1 to +1, right? Normal sine wave. Now what we could do is we could actually, the thing is that if we made the depth 1, then what would happen is that this wave would just, if it's going between +1 and -1, it would only change our main wave by plus or minus 1 hertz, right? In our oscillator data. So here we have the hertz number, right? So which will be the frequency that our wave is playing at. And if we only had a depth of 1, then it would only, if this was a 200 hertz sine wave, it would only go 199, 200, 201, then back to 200, then back to 199, and so on and so forth. So let's say that we wanted to be able to change that wave, let's say 1,000 hertz. So it would go from 200 to let's say 1,200, then back to 200, and then it would need to stop at 0. We wouldn't want it to go into a negative frequency because that wouldn't be good, right? But you get the idea. Let's just say 100 hertz. You have a wave that's playing at 200 hertz. Then what would happen is if you had a frequency, an FM depth of 100, it would go 200 to 300, back to 200, down to 100, and then it would just oscillate like that, right? So that's what we're doing here. Now what we need to do is we actually need to connect this to our oscillator, right? Because the oscillator data does not know about these two new parameters that we've created. So we need to do that in our process block, right? So we have this place where we're able to, we have this code here. I'm just going to put it above our ADSR, where what we do is we get the oscillator and we're able to set the wave type. Now we need to create a function where we're actually able to set the FM frequency and the FM depth. So what I will do is I'll create a new function that will be public. I will say set FM params. That sounds like a sensible name, not parms. We're not talking about Parmesan cheese here. And I will say const, I'm not spelling right today, const float FM. So I'll just call this depth and const float frequency. Just copy this, save me a little bit of typing. Now we just need to write this out. So it's void ask data, and here we are. So now what we could do is we could set the frequency just using our oscillator function set frequency. So we could say FM ask set frequency, and then in here we could put our frequency, or frequency that we're going to get from the value tree or whatever the user sets it to. And then we need to do our depth. So our depth is essentially like our gain, right? How much we want this to control the oscillator. Now the thing is that FM ask doesn't have a set gain function, unfortunately. But what we could do is we could actually just route it and multiply it times whatever value that we get in process sample, right? So what I'm going to do is I'm just going to create a member variable. I'll call it float FM depth, and I will set it to 0. And what I'll do is I will just use this member variable to pass this to where I'm actually doing the sample processing. So FM depth equals depth, like that. And then here, since this is a floating point value, what this function returns here, I can actually just take all of this and I could just multiply it by FM depth, like that. Okay? So that's how that works, right? Now, what I would do here is I'll leave this for now. We can come back and clean up in just a minute, actually. So that is fine. Now, one thing that I found out when I was making this tutorial was that we have this function that's called set wave frequency, and this, I'm just going to open up a new tab here. This is getting called in our synth voice. So if you remember from our past tutorials, we have synth voice, which represents each voice of our synthesizer. And what we do is we have a function called start note, where we're calling set wave frequency, because when we hit a note on our keyboard, we want to know what frequency that the wave needs to be playing at, right? That our oscillator needs to be playing at. So that's how that happens, and that's when it turns the ADSR note on. Now set wave frequency goes back to here, where we say set frequency, and that's all good, right? The problem is that won't only happen if we hit a new note. That only calls if we hit a new note. Now, what if we need to change what if the user changes the FM parameters? What if they change the depth or the frequency? Well, what we need to do is we're going to need to call set frequency, because we need to update what we want our main oscillator to do, because we've just changed the FM depth or the FM frequency. So what I need to do is I need to call set. Anytime I change my FM params, I'm going to need to call set frequency again, so I can update what I want, how I want the main oscillator to react. Now what you see is that we have a problem, right? MIDI note number is local to set wave frequency. See how it's coming in here in MIDI note number? So what I need to do is I need to once again, create a member variable so I could take that and I could pass it down to this other frequency. So I'll say anytime that we're calling set wave frequency, I will create a member variable. Let's just call it last MIDI note, and I will set it to MIDI note number. So that will keep track of whatever the last note that I hit was. And then in here, now I will call that last MIDI note. And of course, I actually need to create that as a member variable. So I will do that here, float. Actually, I'm sorry, this needs to be an int, last MIDI note. So this is just a way that I'm taking data and I'm able to pass it around between functions. Okay, so that's how that works. Okay, so that should be fine. I know it says that we have errors now, but we should be okay. Now I'm thinking, so now what we need to do is we need to go back to our plugin processor. So I'm just going to take that. I'm going to move it over here like this. And now we need to actually call that function to pass this information into our oscillator, right? So what we could say is voice get oscillator and then set FM params. And now we just need to get our actual data from our value tree, right? So what we will do is we will create some, we'll get those parameters. So I'll say FM depth equals audio processor value tree state, get raw parameter value, and then the name of this parameter is FM depth, like so. And I will just copy all of this, and we just need to do the same thing for frequency, like that. Okay, and then we just pass those in, FM depth, FM frequency, like that. We should be good to go. Okay, so that should be fine. Now, what we've done once again is we've just set some arbitrary values here where we've said we want this to be a frequency of 5 Hertz. I'm going to actually set the depth of this to, let's say 500, right? So this will be a sine wave going from minus 500 to 500, and it's going to be oscillating at a rate of 5 Hertz. So let's go ahead and see if this actually works. So we're building, build succeeded. So far so good. And we're just, Ableton's just popping open. And we will have this open. So here we are. And now we are here. Wait for it to do its thing. Now we're going to go down, load up the synth. I'm going to just make sure my sound card is actually set to this sound card, so this is fine. So hopefully this is safe and that it won't blow our ears out. So you might want to turn your headphones down a little bit. There we go. We have a ray gun basically. So if you watch Star Trek, that's what, and here's a square. So I'll just turn this down a little bit. There we go. You've been blasted by a photon ray. So that's how you do FM synthesis, right? So now we have these params. Once again, that's a wave that's oscillating at a frequency of 5 Hertz. So that's 5 Hertz a second, and it is taking the frequency, the fundamental frequency of our main wave, and it's making it move up and down 500 Hertz. Great. So that's where we're going to end this tutorial. And if you've seen our past tutorials, then you know how to draw some sliders and how to set the visible components for your user to be able to actually control these parameters. So I'm not going to take you through all of that again, but this is a good way to get you started in just understanding the concept of FM synthesis and how to actually start setting up your synthesizer as an FM synthesizer. So if you enjoyed this, please give the video a like and subscribe, and we will see you next time.